Welcome to the Valve Studio. I'd like to welcome all the new subscribers as well as everyone who's been watching me try to build some speaker cabinets for my bench back behind me. My plan here is to build 5 identical cabinets, and I've been going through a lot of things with the CNC machine to try to learn how all that works in order to make these cabinets as identical as possible. So I'm going to go ahead and show you in this video how to not do it and the giant fail that my finger joints and my approach actually was. But first we're going to go through some of the CAD stuff because I really have a quite elaborate model for the speaker cabinet itself. You can kind of see it right here. And then we'll go out and show you how I was trying to make these finger joints and how making them out of the stock that I purchased at Home Depot was a mistake. The machining approach that I took was wrong. So this is a completely redesigned speaker cabinet that is completely parameterized, so I can change the width, height, the depth, the stock thickness, the spacings. Basically everything about the design is completely parameter driven. So I'll go ahead and show you a couple examples of that. So let me hit the right button here. So I'm in Fusion 360. So here are some of the parameters that are part of this design. And so I'll change some of these just to kind of show you how it works in the. Let me get this angle right. All right. So first thing I'll change is width. It's right now at 16 5/8. So let's just make it 20. So you can make it 20 here, and you'll see that it is recalculating all the equations, and it's going to make our thing 20. So the top distance across the top is the top depth, which is at 9, and the bottom depth is 11. So let's say that I wanted to make more of a slant on it. So let's say the top distance is now 7 instead of 9. So it will shrink the top end. And it recalculates the face angle. It recalculates everything based on trig. And so it's completely parameterized. As well as the creation of these finger joints over here. The equation that comes through and calculates where these finger joints are makes equal spacing finger joints. The finger joints themselves are not all the same. Well, let me say this again. The finger part of it is the same. That is the, if you look over here, there's something called probably finger width or something like that. But the space between them varies based on the overall width of the top as well as the bottom. So let's set that back to where we were. So that was 9, and this number up here was 16 and 65. So this particular design, I thought a lot about all the machining operations that I'd have to do. So my approach was to take my stock and lay it flat on the CNC, and then cut out the profile, and then rotate it 90 degrees and suspend it vertically with vacuum clamps, and then use a different tooling path to cut the fingers in. But if you think about what's going on here, the top, the bottom, the left, and the right will all have a profile, and then they'll all each have finger joints, and then I'll have to mount them all and cut them all, which will be quite, there's a lot of machining operations and setup to do that. So instead of that, what I decided to do was, let's knock off about 4 of these operations. I'm going to change the top appearance here. I'm going to change the top appearance to, actually I'll change the top. Let me see, how do I do this? I think I have to hit, no, I clicked on the wrong one. Let me, I got to come over here and click on the top like this. I got to do it like this. Let me turn it on, and then we'll do the appearance over here, which has the whole top selected. So what I'll do is I'll change it to walnut, which will just make it darker. And you're going to see over here that here's what the finger joints are actually going to look like. So when I do, this is the left-hand side. When I do the left-hand side now, I can cut the finger joint, the space between the fingers with the coming down in a Z direction while I'm cutting the profile, because now I just have a jagged edge profile. Whereas the top here, the top has is, well, oh man, that's kind of hard, dark to see, isn't it? So the top here is got these circular edges on them. It ultimately in the long run, this saves 2 operations from doing the setup. So what I'm going to do is we will change that back, and there's a reason also why I want to change this appearance. I want to actually do it on the surface because the plywood that I got down at Home Depot is 5-ply birch plywood, and it has a good side and a not so good side. So in order, when I go do the cam operations, I need to keep in mind which is the top and which is the bottom, so that I do the cam operation from the right orientation. So I just made the top, I just made the outside of the cabinet darker, so when I'm doing the camming, oh boy, when I'm doing the camming, I can actually determine which is the outside and which is the inside piece, so that I put them on the machine in the right orientation. So we'll go off and do that now. We'll go ahead and do the cam operations for the we want to do the cam operation for, well, we'll do it for the top. Okay, so we'll come over to the cam. Oh, by the way, this whole design is if you want to copy this into your version of Fusion, you know, just let me know, and I'll send you the link to the URL, so you can just copy this right into your cam tooling. So if let's say that so I already have this thing cut out, so now I need to do the edge finger joints. So if we look at this from the top, this is really hard to get this orientation right on these sides. Well, whatever, you'll see what's going on here. Ah, dang it. I can never get this thing quite set up right. Where's that? Fusion has a little bit of a problem handling this. Or it's probably me. Well, alright, I can't get the orientation right. But basically what I'm going to do is I'm going to, if we look at this part and we look at the other side, oh, dang it, whatever. Okay, so I'm going to suspend it vertically, and then I'm going to come in and cut the notches out and leave these fingers in there. So I'm going to come down here, and I am on the top over here I'm on the top finger right is this one. So this is the tool path that it does. It has 2 passes, and it comes down, and then eventually has the bottom pass, and it does the bottom pass, and then after 2 passes, it's complete. Now I did get a tip. Let me just show you one thing. If you've ever done any kind of cam work for this, let's just talk about doing finger joints in general. Let's say you want to do only 1/4 inch finger joints. You cut everything to a 1/4 inch and you piece it together. When you go to put that together with this many finger joints, it's going to be very difficult to get them to fit, because of the tolerance of however you did it will affect where the fingers actually are, and it'll be really a force fit to go in there, and then there won't be any room for the glue. And so in order to get this to work right, you need to leave a little bit of tolerance in there, a little bit of space in there between those fingers, in order for the glue to have a place to exist, as well as for it to go together pretty well. So I saw a video of somebody doing something else, and I learned this is like a great tip for Fusion. If you come over to my tool path, under the passes step, there's a thing down here called stock to leave. So let's say you're going to do traditional machining where you're going to do a bunch of roughing passes, and you need to leave a little bit of extra in there so that when you do your finishing pass, you take a little bit off and get the finishing pass to look good. So stock to leave is how much stock to leave after to do the finishing pass. So if you make the radial stock to leave a negative number, it will actually cut a little bit more than it's supposed to cut out. It doesn't leave extra stock. It cuts a little bit more stock out. So I've left 5 thou on this particular part, so it's going to cut it 5 thousandths bigger, the space between, and it's going to fit together great. All right, so let's go ahead and do a simulation of this first. We'll let that regenerate, then we'll do a simulation, and we'll show you what this is going to look like. And if I'm blowing through this stuff, I apologize, but let's just get out to the fail part, because you've probably seen a lot of this before. Now something's happened in here, which is lovely. Simulate. So if we come down here, well, this kind of blows. Somehow I've screwed up the tooling here. I shouldn't have changed anything on the other side. That's the problem. I wonder if I can quit out of this and not have it. Oh well, whatever. I'm just going to keep going. You kind of know what we're doing here. So if I come down, you'll see that it's going to cut these finger joints out a lot like this. Okay, and somehow I've got this messed up over here. I'll have to revert back to the previous version. All right. So anyway, make a long story short here. I have a parameterized speaker cabinet. I can change. There are about 20 parameters in there I can change. The finger joints are completely programmable in terms of their width. So I can go in and change the width of these as well. I can change that stock to leave number to leave a little bit more space. I can change the stock thickness. I can do a lot of different things on the parameter side, and then have my cam match up with the real world stuff. And everything works great over here. And then once you get out to the shop, you find out that it doesn't work like this at all. So let's get out to the shop. I'll show you how I failed. And my approach is great for pine, but not so good for plywood. All right, let's go out to the shop. So this 5-ply half-inch birch plywood comes in a sheet that's 24 by 48 from Home Depot. I cut it in half, and I used the blue tape and super glue method to hold my workpiece down. And I apologize for the ideal placement of my vacuum hose here. You can't see any detail about what's happening, but you can see that it's cutting the finger joints on one of the sides here. This operation took about 6 minutes, but all the videos in this video are accelerated. They run about 600 to 800% speed, except for one. I'm going to show you the one, and it's running in real time. So that went pretty well. Start out with. So this dust nozzle I made is a 3D printed part that collects about 95% of the particle coming off the bit. That hole there is a little bit larger than the nut on the end of that chuck to hold the bit in. And this allows me to have almost full excursion on the Z-axis of the machine. This works pretty well for the blue tape method, but that dust nozzle will get in if I have some workpiece holding. It'll bang into it. And for those of you skeptics on this method, I gotta tell you, I had 3 strips basically of tape with a little bead of super glue, and you'll see here that I can barely get this thing off of here. And I'm not too strong, but it's on there. So this is a great method for doing work attachment. Unfortunately, this tape pulls apart the little fibers out of the back of the plywood, so you have to use the tape on the back side. And here I'm doing a little bit of cleanup. I'll go ahead and show you these finger joints in slow, regular motion here. So it looks pretty good. So at this point I was really happy. Here's the first end joint I'm probably doing the top. My first attempt at doing the cam. What you can't see is that on the other side of the stock, it has lifted off almost all of the outside layer, which is the birch piece. It's not, doesn't look very good on the other side. But at this point, I'm still okay with the performance of it. It's just not really ideal. I'll show you the finger joints here in a minute. Okay, so you can kind of see that it's ripped off the top layer of the plywood. And you can also see that these rounded joints are not quite rounded, and it turns out that this 1/2 inch stock is not 1/2 inch. It's actually 50 thou narrower. So I remounted this piece after I went into my cam program and changed the stock thickness to 0.45. And I came back in and I figured, well, I don't have anything to lose here, so I might as well go ahead and recam this part. So because this is actually I have a fixture to hold the stock in the right position, it's relatively simple to put this back in and do another operation on it and have it be somewhat accurate in the placement. But as you can see, my secondary operation basically tore the crap out of this plywood down at the end. And this particular plywood is not very good quality. I'll leave it there. The middle layer there, you can see that it's 5-layer on this last little finger that's sticking out. 5-layer plywood. The 2 end layers are really, well, it might be even more than that. But across different finger joints, the major middle piece of this plywood is not sufficiently glued. So if you look down towards the back side of that, there's major pieces of the center of the finger that I pulled out during the machining. So I made a decision to let's try a few different things, and we'll show you that here. Now this piece is actually running in real time. this entire piece is running in real time. And I modify the feeds and speeds along the way to show different outcomes. I'll go ahead and zoom in here so you can kind of see what it's doing. Now, also keep in mind that I'm not going into production, so even if it was this slow, I wouldn't mind. But it turns out that this is too violent on the piece as well. You can kind of see major pieces of it are flying out there. So I took another approach where I ran a bead of wood glue along the top edge there in hopes that the wood glue would hold the middle ply in during the operation, but that didn't work either. Well, that was a total fail. The feeds and speeds could not be adjusted such that the end mill would rip the crap out of the end of the plywood. And this is plywood I got at Home Depot, and it has a wafer thin veneer on it, and also it's not glued together very well, so the inner layers are somewhat loose, and so when the router bit comes through, it rips those loose pieces out. Fit-wise, it went together really well. In fact, from a tight fit perspective, I used a little mallet and hammered this together. But it doesn't. It got some height problems. Let me see if I can show you that now. This is proud here, and it shouldn't really be that proud, and so something else is going on. But it's really hard to tell because my ends of my cuts are so crappy. I can't even take measurements on this. So I'm gonna have to think about a different way of doing this. I'm not in production. I'm gonna make like 5 of these boxes, and I'd like to stay with plywood only because it is a little bit flatter than just regular, like flat pine or something like that. And I can just measure it and adjust my cam to fit the thickness. So I have now 4 pieces of scrap to try again, and I think what I'm going to do next time on my next iteration is, okay, you see this is the bottom piece here. So I was just cutting this out as a rectangle, and then I was machining out the finger joints on the end. But I think what I'll end up doing on my next pass is to go ahead and cut the finger joints in this while I'm flat on the table. While I'm cutting the perimeter, I'll go ahead and cut these finger joints in, and then in order to square them off, I'll go ahead and put them in the vertical orientation, because the majority of the material now has been removed, and all I got to do is lop off that little the radius of the bit, because the end is going to kind of look like this, and all I got to do is, if I go in the vertical orientation, all I got to do is lop off these bottom round points. So I think I'll try that next. I'll go ahead and fashion up a demo joint in Fusion, and take my scrap here. It's $25 down the tubes here, but it's part of the education. So I'll continue to work on this because I'd like to use plywood, but I don't know. We'll have to see. Well, that's it for now. Thanks for staying here to watch this total fail. All right.